All right, this lecture is going to cover raw files and conversion for public databases. This is Emma Dowd, again, Assistant Director at the IUSM Proteomics Core. So we're going to cover what a raw file is, some other types of these, what sort of files are recommended or required for public databases, and what options there are available for you to look up data from public databases. So what's a raw file, first of all? First of all, a raw file is the actual data that you're getting off of the LCMS. So it's vendor and instrument specific. And you're going to need vendor specific software to directly open these files, although there are different file converters that are available for free online. So if you do find yourself with a raw file that you're unable to open, you may be able to find some free software that will allow you to view. And for thermo instruments, it's Freestyle or Excalibur, Mass Hunter for Agilent, Bruker, SciEx, they all have their own proprietary software. That's kind of the major thing. It's communicating with the mass spec and it's creating these data files. These will also contain a lot of your method information. So if you are able to ever view or look at these, you'll be able to tell how the mass spec was run, what sort of gradient was run often, how long, and what sort of detectors and scan rates were used. So here we have an example chromatogram of just a total ion abundance, relative abundance over time. So this was a 180-minute method. Thermo uses a .raw for the end of their file name. So anytime you see probably a very large file with .raw at the end, it's probably directly from the mass spec. This is an example of if you're clicking through this raw file, you'll see your precursor scan and any fragment scan. So a precursor scan, you can see here at the top, this is where you'll get a lot of the different information about what you're looking at and what the method is. Again, we're always using relative abundance as the output from mass spectrometry. Here we're using FTMS, so it's an Orbitrap or Fourier transform mass spectrometer. For the precursor scan, we're using nanospray ionization, and we're doing a full mass spec precursor scan from 375 to 1500 M/Z. Here at the top, you have the scan number or the retention time that you have clicked on in the chromatogram, and the average abundance in this the scan. And so here you can see all of the different ions present in one precursor scan. And so in previous lectures, we talked about different methods of acquiring data, data dependent or data independent. And you'll be able to walk through your raw file and see what sort of method was used and how the data was acquired. So here, it's a data dependent acquisition, and an MS2 scan was taken below on the precursor scan 568.8581. So if you look back at your precursor scan, you can see that this is a very abundant ion here. It was selected as one of the most abundant ions and fragmented, and you can see in the scan title that it was fragmented in the Fourier transform mass spec, so in the Orbitrap. So yeah, you can get a lot of different information from your raw file, and if you're running some specific experiment on a single protein or a set of small molecules, for example, you might want to practice looking at the raw files directly, because it could be something that would be really important for your data analysis. However, in large-scale proteomics experiments, these raw files are really complex, and you're not going to be able to just look at this precursor and fragment ion and determine what peptide it goes to. So later on, we're going to talk about some of the different data analysis and visualization softwares that are available out there. So, okay, you have your raw files. Maybe the core has given you some output and you've written your paper and you would like to submit it, but it is getting really important that your data become publicly accessible. And in the past, this was a challenge, mostly because a lot of the mass spec files are very large. And so until relatively recently, there wasn't a great solution for making data easily publicly accessible. It's just you're taking up so much storage space with all of your different files. But the field has moved to a few different databases that are most commonly used, Proteome Exchange. And you know, if you're getting ready to upload for a paper submission, you're going to want to think about what the journal requires. So there's still plenty of journals that do not require you to upload your data, but it is good for visibility. They might have a site on the journal submission form for you to upload some data or link to it. For some small projects, you might be able to just show the raw files or just the results included. It really just depends on what sort of paper you're writing. But if you're writing a larger proteomics paper that's really looking at extensive data analysis, or if you're writing scripts or you're doing multi-omics sorts of papers, you're probably going to want to do a proper Proteome Exchange upload. And when you do this, you're going to need your raw files, but you're also going to need peak and results files. And these files are exported from whatever processing software. A peak file is processed data. So it's a raw file that's converted to a format that can be then searched with a database. And then the results file is obviously the results of the database search and FDR calculations. And you're going to need to check that your formats are correct for either the journal or for the Proteome Exchange upload. Places will say that you can optionally include the direct output from your search software. So that will often be some sort of proprietary file output where you can only open the results file if you have the correct software. So that's some of the reasons these peak and results files have to be converted to a more general format. They will request sometimes that you include any protein sequence databases used to search the data, any gel images, metadata, just to have a very complete submission so that anyone who clicked on your Proteome Exchange FTP site can really view everything, and it's good transparency. I will say up here that for bioinformatic focused papers, we have often seen that labs will create specific GitHub sites to contain all the files and scripts. So if you're into a more bioinformatics sort of world, GitHub is also a good option and completely acceptable in the field. So again, popular public databases. This has really grown a lot in the last year, and I invite you to view the Proteomics Standards Initiative and Proteome Exchange. And Proteome Exchange is a good way of viewing all sorts of data. Both of these will list requirements for full or partial submission, and they often have a private or reviewer-only mode that allows you to submit your data and get a link that you can send to reviewers, but the data is not publicly accessible until your paper has been accepted, and you can email and create a public accessible data. So some more components of the Proteome Exchange Consortium. This is where you can view all sorts of projects that have been uploaded. And they've been working, again, it's over the years, the different databases and groups have really come together, and Proteome Exchange has been the final source. And you can see that a lot of these are archival or focused resources. And so if you do have some specific project, you might want to look into Massive or Passel. But we use this Pride, has a relatively easy to use GUI for data submission. And this Pride uploader will allow you to make a complete project submission for Proteome Exchange. You can view archival data, so anything that's been made public is accessible by search at proteomecentral.proteome-exchange, this link right here. You can kind of view all the different data sets that have been uploaded. It's some really interesting visuals on their website. So definitely take a look. You can search then by specific disease. So it's worth thinking about this because there might be some really interesting data already curated and present in the world that could be researched or looked at for your specific needs. So after you have sent in your data and created an upload submission, you will receive this PXV number, and that is included in your manuscript usually, and it's this original data set. So this is an example of an upload which I did late last year, and then made public in February. So this is all the information that you're including when you upload your data. So you have all sorts of instrument type, modification list, what sort of species was used, obviously the title and description of the sets of experiments that were done. So this is just an example of what the final PXD file looks like. And then at the bottom, there will be an FTP and URI site for data download. And that's it. And please let us know again if you have any further questions about this.